Sandblasting was an awesome idea 15 hours ago. Like dentistry and drywall, large-scale sandblasting is one of those things that costs a fortune to pay someone else to do, and it's worth every penny. Since this is going to take a minute, let's learn a few fundamentals about the basics of sandblasting while our friend here waves his magic erase wand. On October 18, 1870, the American soldier, entrepreneur, and inventor Benjamin Chew Tilghman patented the process for sandblasting. Chewy's creativity established concepts so enduring that the last company he founded, the Wheelabrator Group, is still in business today. The hull of my boat is made entirely of steel. That steel has spent the majority of the past 36 years outdoors and half submerged in water. Judging by the dings, dents, and damage, some of that time was spent bouncing off everything from rocks to docks as well. She spent most of her lifetime in areas of Michigan and Canada, where we have 8 months of winter and 4 months of bad sledding punctuated with tornadoes and ice storms just to break up the monotony. If you're ever thinking of vacationing in Michigan, don't. We have mosquitoes year-round that go up to 6 kilos. They feed on murder hornets and are known to carry away small children on occasion. Take a look at what happened to our last famous cruise ship, the Edmund Fitzgerald. You'd have thought people learned about the problems of icebergs and cruise ships with the Titanic. No, the Fitz sank in the 70s, and Lake Michigan is still the deadliest body of fresh water in the world. If you insist on trying out the tourism of the Great Lakes State, at least stay somewhere safe and welcoming, like Detroit. As a result of our abominable weather and a previous owner who is so stupid he thinks that helm is a new gender pronoun, this poor old boat has considerable pitting, flaking, pocks, dents, and even a few holes. Our mission is to not only restore it to a like-new condition, but to make it better by leveraging the advancements, achievements, and progress that the past several decades of technology have brought upon the world. Sandblasting, properly called abrasive blasting, is the process of shooting a stream of media under high pressure against a surface to transform its properties in predictable ways. With abrasive blasting, we can modify a surface to be either rough or smooth, we can shape an object, remove contaminants, corrosion, and coatings, and even harden steel surfaces. The final effect is similar to using sandpaper, but abrasive blasting is far more efficient and works better in corners, tight spaces, and complicated shapes. With the right equipment, it's also substantially faster. Experimentation showed it would have taken roughly 600 hours to do the surface preparation for this boat with an angle grinder and God knows how many dozens of flap wheels. A husband and wife team with a janky old professional blasting rig did it in a weekend. My shoulders would like to thank all of the supporters on Patreon who helped out and kicked in a couple bucks on these projects. You guys made it possible to hire the blasting company and saved me suffering a sweltering summer holding a grinder over my head for weeks on end. My quadrageneric deltoids don't find that humorous, and I passionately appreciate your help. Thank you. In almost all forms of abrasive blasting, the media is propelled by either pressurized air or water. There are other means of blasting, most notably wheel blasting, where an impeller is used to fling ablative media through purely mechanical means. It's the best industrial process for showing just how violent things can get when shit actually hits the fan. But that's not something that the average person getting into abrasive blasting will ever come across, so we're not going to get too deep into that one. Maybe in a future video. Comment below if it's something you're interested in and let me know. A sandblasting rig most often comes in one of two forms. Large mobile rigs like we're using here tend to be the pressurized type, with all the media stored in a steel tank that's held under high pressure. The rig will have the media container, called a blast pot, and a large diesel air compressor. Smaller mobile rigs will have the compressor on a tow-behind trailer like we do here. The air and media are mixed through a special metering valve, and the entire feed line out to the operator carries both dispersed media and high-pressure air together in a single tube. For rigs like this, the operator usually uses a wand-type tool instead of a smaller gun-type tool that you'd find in a blast cabinet, because the scale of the job is much larger and the work isn't as precise. According to the owner of the blasting company, this machine outputs 650 pounds of sand per hour. As one of the people who had to shop vac sand out of the boat well into the small hours of the morning, I believe him. Remember, every grain of sand our friend here blasts into the boat has to be vacuumed out before I can paint it. Blasting media, the actual particles that are being carried in the compressed fluid stream, is the stuff actually doing the work. Depending on what you're trying to accomplish, there's a wide variety of blasting media that you can choose from. Back in the beginning, they thought that sharp edge particles worked the best. Over the years, that's been proven false. Now in America, we're slow learners. The most common abrasive blasting media is silica sand. It's cheap, easy to get, and works well for the job. The problem is that it breaks up very quickly into finer and finer particles and creates a huge amount of dust. The dust, being made of silica, is a major cause of silicosis. This is a debilitating and often fatal lung disease that has killed many thousands of people over the years in a slow, agonizing manner. And it's still a common cause of death among people who combine cavalier attitudes for safety with the choice of choosing sandblasting as a career. To help counter the safety problems of silica sand, you can often find forms of silica blasting media where it comes coated in various resins to help control the dust. How well this actually works depends on a ton of variables, but as a rule, it's best to just avoid actually using silica sand in the first place. Plenty of other options exist, the difference in cost is comparable, and almost all of the other options are substantially safer. Because of these facts, silica isn't even allowed as an abrasive in major parts of the world. Belgium, Germany, Russia, the UK, and Sweden have banned it outright. In the US, though, it's used everywhere, including on sandblasting my boat. I didn't know, and I didn't get the choice, but now, you know better. A lot of people who don't actually do physical work for a living like to buy their jeans already worn out. These people are posers, and desperately need to spend more time outside playing in the woods and exploring abandoned factories. Aside from the poser aspects, an obvious lack of financial acumen in purchasing jeans that are already half worn out, is the fact that many of the companies that make them do it by taking perfectly good jeans and sandblasting them. Because of this, over 5,000 people in the textile industry, a business with a long and lovely track record of worker safety, are dying of silicosis. If you want worn-look jeans, just buy new jeans and go outside and play. It's healthier for you and for the forgotten people in the third world shithole that made them. A great alternative to using silica sand is to use garnet. It's inexpensive, easy to get, works almost exactly the same, and doesn't have nearly as much dust. Garnet dust also has the advantage of being much safer than silica dust when you invariably ingest some. Other medias vary from super aggressive things like steel shot and needles, down to very gentle things that aren't even really abrasive like dry ice. Across this spectrum we have things like ground up walnut shells, sand, glass beads, crushed glass, pulverized foundry slag in several flavors, ground up plastic, corn cobs, and even baking soda. Steel, stainless steel, copper, and aluminum shot, as well as other blasting media, is commonly used for heavy-duty applications. You can even use this for a blasting process called shot peening, where the surface of a steel object is deformed by millions of tiny dents, and the end result is creating a hard candy shell on the surface by the stretching and compressing of all the little craters. There's a huge variety to choose from, and some of the effects can be pretty cool. By choosing the right media with the right tools, you can do abrasive blasting on everything from tombstones to eggshells. The other main type of blasting rig you're most likely to come across is a siphon tube blast system. In this design, the media storage isn't pressurized and remains open to atmosphere. The blasting tool, either the gun or a wand, has two tubes, one of them with clean, high-pressure air, and the other is a feed tube for the media. The blasting gun has a venturi built into it and causes a vacuum in the feed tube that suctions media up from a reservoir, which is typically made from the bottom of the blasting cabinet. This allows media to be recycled back into the blasting process over and over again. The end-of-line tool varies from rig to rig depending on the application of that job. Many of the components are designed to be hard-wearing and replaceable. Nozzles come in a multitude of materials. Tungsten carbide is the liner material most often used for mineral abrasives. Silicon carbide and boron carbide nozzles are also very wear-resistant and frequently used with hard abrasives such as aluminum oxide. Inexpensive abrasive blasting systems and smaller cabinets use ceramic nozzles. They suck. The hoses suffer constant abuse from just working in such environments, and the ones used on the large rigs where we're carrying the pressurized media down a single tube often suffer from holes, leaks, and even blowouts. This mostly happens near the wand end where the hose is often held at a tight angle. The media flying down the tube bounces against the interior walls just like light in a fiber optic cable. When the tube is held at an angle, this creates a hot spot on the inside of the tube as the media eats away at the rubber. Eventually, it'll fail at this spot. The wands are designed to quickly and easily detach from the tube so that the operator can cut a few feet off and reattach the gun in just a few minutes. For the operator of a rig this size, he's wearing a special helmet that works under positive pressure. He's dragging along an air hose that is supposed to, at least, be feeding Grade D pressurized air. Grade D is where the air meets certain standards for the minimum amount of oxygen and the maximum amount of oil. Grade D is monitored for things like carbon monoxide and filtered for oil, taste, and contaminants to make it safe. Grade D is about as low as you want to go with simple air that you're actually going to be breathing. Good systems will provide Grade L air, which is much better. Grade L is the quality standard for things like scuba tanks. The scary thing is, a lot of guys out there end up with Grade A air, which is pretty much just straight off the compressor. Without monitoring for things like carbon monoxide, people have died from breathing air where the compressor intake was next to the exhaust of the diesel engine that was powering it. You can also have a huge amount of oil floating in it, and that's yet another in the long list of breathing dangers for a guy running a sandblasting rig. The other big danger coming through the air for these guys is the one that you never hear anyone talking about: sound. Blasting is loud as hell. And the fact that in this application here, on the boat, he's working right up against a hard, smooth surface just means that not only is the boat acting like a big sounding board as the hull is actually ringing like a bell, it's also reflecting and dispersing all that noise right back at him. It's unimaginably loud, like rock concert loud, and you can easily hear it half a mile away. Combined with all of this, whatever is being flung out of that nozzle at high speed is bouncing back off. Protective clothing is a must, and real operators typically wear a lot of canvas, leather, and other heavy materials. They get to find the balance between roasting in the heat and getting shot at all day with tiny, stinging bullets. These particles, shooting back at your face, often hit the visor on the helmet. As they do, it gets etched, resulting in a frosted glass type of look. Because of this, it has a replaceable viewport covering. The cover is good for about an hour in this particular rig. You can't really see well to begin with, about as well as using a welding hood, and it only gets worse from there as the viewport lens protector gets etched until the whole world is just fuzzy blobs. This man here did all of this, outside, in full sun and summer heat, while not only doing the outside of the boat, but all of the tight little spaces like the cramped aft steerage compartment, and most of it while deaf, roasting, choking on bad air, half blind, and collecting sand in places you don't even know you own. It's a hell of a way to make a living. I want to thank Roma and his awesome assistant Reina, who came out and did all the blasting for the entire boat in a weekend. They worked their butt off, and I am amazingly thankful for all of their work. Thank you guys for being awesome.